going on, everyone? Hope everyone's having a good, what day is it, Wednesday? It looks like we have audio coming through. Just going to make sure that that is in fact working. And it looks like that is an accurate statement. I'm going to go ahead and log in to Microcorruption. And hopefully type my password right for the password manager. And there we go. All right, let's switch this on back to desktop. So anyone who watched yesterday would have seen that we struggled a lot trying to make things work. I realized this morning that some of the constraints that I was putting on the values for the original strategy were not, in fact, required. So I'm going to open up my notes and do a little recap of where we were yesterday. So in Lagos, we have this lock, and it is a very simple stack corruption vulnerability. We found 17 bytes gets to the overflow, and that lets us overwrite the return address on the stack. That works totally fine. We can verify that. We can do that. The big problem is writing our shellcode. We can use either ROP or shellcode because the stack is executable, writable, and readable. But the input is limited to only alphanumeric ASCII characters. And I mentioned yesterday that the way that this system works, everything is 16-bit. So we are doing effectively like 2 characters at a time that are packed. And yeah, so we have limited gadgets we can use. ROP is an option, and it just so happens that the ret instruction is alphanumeric. So we could swap back and forth between ROP and shellcode if we wanted, because we don't have ASLR, and so the stack addresses are consistent and we know them. We don't have to leak it or anything. So if we wanted to go back and forth, it's totally an option. But the biggest issue that we had, hey, Mr. ED Mix, thanks for the follow. Hope you enjoyed the stream today. So the issue is like we haven't really been able to find like a good way to make this happen. The first approach we tried yesterday was doing some addition with these large numbers to effectively get our R2 register or the status register SR to be FF, because FF00 is the syscall that we want to make, or the interrupt we want to do. I'm going to open up the assembler and the lock manual and just pop this open to show everyone what I'm talking about. So the way that this specific processor is implemented, there are interrupts, like software interrupts, that are defined specially for this modified processor, and the interrupts are passed in the high bits of the SR register. So if we look at SP430 SR register, we'll see here, like this is how the register is laid out. We see that the top 8 bits basically aren't used. These are reserved. And so these are co-opted by this processor to handle software interrupts. These are the ones that we need to avoid in the low 8 bits. But there's a whole list of all of the interrupts here. And for whatever reason, they chose to write it like this, and this isn't actually how it works. It does some magic under the hood. But the way that it works is that this 7F is actually FF. Once it does like whatever magic it does, which is like doing some bit shifting, and it ends up being FF, which unlocks the lock. So what we're trying to do is add up a whole bunch of numbers that will eventually get FF00 into this register. The problem is that we need to make sure that this bit is never set. Setting the CPU off bit will literally turn the processor off. And so we need to make sure that the numbers we add up never set that bit. The problem yesterday, and so I found this set of numbers that will add up, and these contain these are all like two characters when you write them, and these are all characters. These are all 16-bit values where the two characters that they represent are alphanumeric ASCII characters. And so the thing that I said yesterday, which led us down this path of it not working, or we couldn't find a constraint that satisfied it, was that this this value right here can never be odd, I think, was effectively what we got to. And the reason we said that was because I was thinking that it was going to set this, but that's just not true. We can have an odd value. Well, I guess that maybe is true because it would be odd or could be odd, because it affects like an AND operation. So maybe that does hold. Anyway, we can try something new today. The thing that I wanted to try was trying to use Z3, the theorem solver, to give us a set of numbers that are gonna let this work. What it may do is it may tell us that this is unsatisfiable, so like we can't give us a set of numbers, or it may tell us that like it may just spit out the values that we need. The one thing I'm going to do before we jump into trying to figure out Z3 enough to do this is I want to make sure that I have enough control over the stack that I can move to our shellcode, start executing, and then ret back to effectively like returning to a call 10, which is how we invoke the software interrupt. So we are going to create a new exploit. I don't think that this matters, but we'll leave it here for now in our notes. And so we are going to need to fill our buffer. This is, I believe, 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. That's 17. So this is going to be our first return address. And then we're going to have ret to call 10. And then we need to have some padding. And then our shellcode. So, the reason we have to have the padding here is because we need to get a thing that we jump to, like where the shellcode is going to be, into an ASCII printable, not ASCII, I keep saying ASCII and it's not ASCII, a alphanumeric address. We can see here, like when I get the stack moving, our stack is right here, and so we're gonna get so we're gonna hit here. We see our A's right here, but what we see here is that these are not alphanumeric characters, and so we're gonna have to push down into this region where we get to something that's printable. Not printable, alphanumeric. Keep saying printable. So if we want to look at where we can start, we also need to make sure that we're always 16-bit aligned. That's another big thing about this architecture is we have to be 16-bit aligned. The first address that we can use is 30, so 4430 would be right here. This is where we have to start our shellcode at, effectively. So 4430. That's 0 and D. So that's 0D. We also need to find ourselves a call 10 that is going to be alphanumeric. I'm going to jump up here and see like what we have. And feel free to ask any questions if you have them. Happy to kind of go back over any of this stuff while we work on it. This might be the other problem we have, is that where the call 10s are, they're not alphanumeric. So yeah, this is not going to be alphanumeric right here. That's one option. So like these calls right here are technically usable, and these invoke the interrupt handler. The only problem with them is that we have to have our value on the stack. And we don't get to do a push, unfortunately. Is this really all that we're going to have our option of? Let's go to our assembler and see if what we can do here. So we're unfortunately not going to be able to use this. We're never going to be able to find this, most likely, because we're going to overwrite the ones that we actually have access to. We saw in here, not there, in right here, this is a naturally occurring branch, like R4, I believe. Yeah, it's a naturally occurring branch R4. We unfortunately won't get access to that. Let's, I guess, see like how much space we get to write and see how far down the stack we can get. Like maybe it'll give us a hint that like that's how much space is needed. Because this is the big problem, is if we can't invoke the interrupt handler, we're kind of screwed. And I guess if we find like a 0, oh no, we wouldn't be able to though, because the 0's gonna get overwritten because it's down the stack. Like like it's gonna be here, so we can't put a 0 in here. can't ret any of this stuff. So maybe we need to build it onto the stack, and I think this is going to be an issue, is I don't know that we can necessarily do that. Let me reset this real quick, and let's see the value of our registers by the time we return out of this. That. Zero D. This isn't going to actually bring us to anything, at least useful. That's interesting. So, 4130. So basically, like, these are. I'm going to get the last character of my. Wait, why is PC at. Hold up. Where's the stack? So this is our return address right here. So 44th 3C. Yeah, so it's 44th 3C. So it should be. Did I not count that right? So this is what, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. Oh, so it's two. It's this is 16. It is 17 bytes. Okay. So. 4430. That's so interesting. So even though FF is, oh, because it's 15, it's not SR. I wonder if theoretically eventually it'll hit this. Or go into an infinite loop. Oh, I bet. Did it die? 4438. I think we just overwrote, like everything was zeros, and it's just doing nothing now. Yeah, continue from there. So we got a few registers that have values in them, and we have control over. So R11 has, I think, the last 2 bytes of our input. So it's a starting point. R12 also is 2600, which I don't know why it does, but it does. And I guess we could technically hit this up to 6F. 6F. That's not like something useful, is it? Nine, 5. And so here's the issue that we have is we got to find a way to get our stack to have something like meaningful on it. Like we can. Yeah, this ends up not being helpful. So this is a read primitive we can use. But we don't really have like a write, which is our issue here. 4030. What does that disassemble to? That's interesting. F246. So this is one thing I don't quite understand is why this assembles to BR 46F2. Yeah. So we can do a branch. We just don't get to branch to 10. Unless we can find like a naturally occurring 10. It's an option. So can we find a 1000 in here anywhere? That's not printable. Unfortunately. Or it's not alphanumeric, unfortunately. Although, I mean, we could build a NOP sled. Four, 5, F 0, 1, 2, 3. 4, 5, F3. Minus, what is this? 4, 3, ED. It's 518 bytes. How many bytes do we get to write? Where is login? $200 hex. We are just under that. Man, that is unfortunate. So that's interesting, though, that so this is branch R4, 0044. And this is 4030. I wonder if like 40 is just the branch instruction. The move destination to PC. It's interesting how they implemented that. So a move instruction is zero. So 1, 2, 4. So it's gonna be 4. Cool. Okay. Yeah, that makes sense. Okay. So are any of these... Huh. So we find a naturally occurring 0, 0 as... Oh, no, we'll never be able to do that, though, because the low bit is 0, 0. The high bit is 0, 0. That's unfortunate. I thought that we were gonna be able to do this with the 10s. It kind of sucks. Like if we could just get to right here, we'd be set. Like we just can build right there. What 2400 is. Jump 0. Let's do. B012, I think that's a call or something. B012 8C46. I think that's a call. Yeah. And we can't overwrite the address that it calls, which is an issue. wonder why R5 has 5A08 in it. Anyone got any ideas? So, this idea was good. We might be able to do this with Z3, but we still don't have a way to get to our interrupt handler right here. We know we can't wrap around, unfortunately. We can maybe do like a backwards jump. I think we figured out that we can't do a an and. Like we could potentially like and off some of the bytes from here. What's 4400, and like does that end up doing anything? Like say we were able to just get PC to start like here, like would that execute anything? Would it do anything meaningful? Yeah, so that's the problem, is that we're gonna do an RRC. I'm still not exactly sure why we can't execute this. Oh, because it would wrap, and that's why. Because it would end up the PC ends up going over. Why would it wrap? 42440044. Like that's. I mean, not that that like really helps us. We're just in a bunch of zeros here. If we end up doing that. Kind of curious what the other ones are. If we go and look at like another one of these challenges, is there anything at the end, or is it just a bunch of like what's 4844? Oh. I wonder if it's coincidence then. Like 4644. Yeah, that seems to be continuous and maybe not having to do with it. Like maybe that was a red herring the whole time, is that like it's unexpected. It just is ret I PC. T37B. Oh, so it's just in the zeros here. So we don't get to overwrite that. We'll never make it down to here. Interesting that it... I wonder what ret I does. Return from interrupt, pop SR, then pop PC. Four six F4. If we return to like, what was our call unexpected there? This is printable. 4.2 is B, 4.4 is D. Yeah. Are you asking if that is return from interrupt, or asking what return from interrupt is, Mr. DMX? It's BD. Oh, yeah, it looks like you were right. I'm not exactly sure what that does, other than like doing the popping that it suggested. I wonder if we have the stack in like a more meaningful value, if we can get other better values into SR and into PC. And we said that it was... where's that? Have you worked with MSP 430 before, or is this your First time seeing any of it. It's BD. So we're going to continue. So then looking at, oh, that's interesting. This is why that was getting into R5. So looking at where stack pointer is, we so doesn't help. Oh, cool. Yeah, so the MSP 430 is like a real processor that's made by TI. It's used for like it's a microcontroller. It's done for like a lot of embedded development. But yeah, this is like a whole virtualized one of it. I haven't really done much in the Linux kernel, but I have done a lot in Etherland. So it doesn't seem like this gets us anything meaningful. It says that it pops, what was it, like SR and then PC. But, I mean, the stack pointer's up here, and none of those values got popped into SR or PC. So, I don't know that helps us in any meaningful way, other than, like, get us stuck here. So what are our options now? We still don't have a way to get to 10 or 16, which is like the biggest issue is not being able to get to here. Like we could theoretically get to one of these calls, but we don't have the stack in a meaningful state where we can pass it a 7F or FF 7F. Because we'd have to pass just 7F. 7F is... What is 7F? Is delete. I suppose maybe we could and off the high bit. But we don't get XOR. I don't know if we get and. No, it doesn't seem like we got and. Because these 6363s are like that F0 is not going to be usable. And if we do and B, we're not going to have any value here, which is a problem. Decimal add source to destination. Does it, what do you mean decimal add source? Weird. So we're not going to get this. Maybe we could do a bit clear. I mean, yeah, we're not going to be able to get that. I wonder if we could find a way to modify this and change the... I mean, I guess we couldn't because we would never be able to write the 3012 there because it's not alphanumeric. Unless we can get like a indirect access to that that byte. I think we did. Oh, we do have this. That's into R15 though. We don't have it like onto the stack. So we could write a 0. To 4 bytes from something printable. Does a 0 help us? Not really. I wonder if there's some way we can, like, we could get 4600, I guess. We can find like a something that like masks off the lower bits, or we have a 0 on the stack that we We're gonna overwrite that though. We can't do like a we won't be able to do clear. We can't do push. Can we add directly to the stack? That. Oh no, we'd want to do it this way though. If you want to dereference it. That does not work. Is there a different way to dereference that I'm doing wrong? Maybe it won't encode the 0. Get lucky. No, it's the same thing. Register is incremented by 1 or 2. We decide that we don't get BIC. Rotate left. I wonder if we can get RLA. Immediate mode only valid for source. Did I do that wrong? Rotate left. Okay, so it'd be RLA dot like 32. That's interesting. It looks like so like the major things we get access to are moves, adds, and ret. Beyond that, there's not a lot of operations we get. We get pops. There must be something that like I'm missing, because like this isn't that, it's not meant to be that hard. We're not going to find a naturally occurring 7F. I don't think on the heap, or on the stack. Yeah, there's nothing. Like, maybe we could move the stack down a bunch. Yeah, and this is the problem, is we can't actually get into here. So 463. Four 60. So I mean, theoretically, I guess we could overwrite this with a branch, or just overwrite this put our shellcode here and have it fall into the call there. Is it 445C? It's 407. So so 407. We could try doing this and see if we can get to the point where we like write something like worthwhile. So is 5C printable? I see it's L. It's L, and 4 is D. L D. So running this will get us to that's interesting. It is LD, right? Four, 6. 4, 4. You hear? So 4, 4, 5C. Oh, 5C is not alphanumeric. 5A is though. 5A is Z. So ZD. So if we ignore the fact that there's pushes here, because we can put whatever instructions we want there, SP is pointing to 3140. Can we get there's no naturally occurring 7Fs. Is there anything that we can use to write to SP? We can zero out stuff, but that's it. This is the worst, because this is like almost what we need. We found that we can't do this, I think. Yeah. So we don't get to do that. We don't get to do that. We don't get a push. Like, if we could find like a 7F or something, or get some kind of like and we got ideas how we can get a 7F somewhere onto the stack and then move our stack pointer there. Like we can call int, we just can't get something on the stack that's meaningful to us. And there's not like any like push gadgets we can use. And, like, we can really like move down the stack if we want. I just don't see. I mean, I guess we could call gets. And we could read in our own new data, maybe. Like, is gets alphanumeric? Get char, put char, get string. This is... Yeah, so we are trying to do that. We already have that. You can see here if I do this, 17 bytes of data. 17 bytes will get me to the return address on the stack. So I can do, like, say, BB, and I'm gonna continue here. This is the ret in the function where the overflow is, and you can see that when I hit S here, I'm at 4242, which is BB. So I have control. The constraints for this problem are that the characters that I can enter can only be alphanumeric. And what we want to do is call an interrupt. We want to call software interrupt 7F because that unlocks the door. The problem is that there's no naturally occurring 7F anywhere in the address space here. So we don't get to we can't just like put it on there ourselves. And we have limited gadgets if we want to go the ROP route, because we only have the gadgets that are alphanumeric within here. And I can write shellcode, but the shellcode can only be alphanumeric. And maybe a better option is that we go the route of returning to get string. And we can then bypass all of the craziness there, because we can pass in our own values. Like if we go to login here, we can look at the calling convention. It looks like you pass the address to R15 and the amount to R14. And I think we have pop gadgets for that, for 14 and 15. We don't. We might have shellcode, though, that works for it. Yeah, so we can write that. So, I mean, that works. We can enter 500 bytes, I think. 512 bytes. Yeah, 512 bytes. So we have a lot, and like theoretically, like we could write an encoder, but I don't really want to go through having to write an encoder. It seems like it's beyond the scope of what like we should have to do. So, say we go this route. Pop R14, pop R15. Whoops. Are those not printable? Or I mean that they're not alphanumeric. But, so maybe we can't do pops, but I think we can do moves. So we do like 4-2, 4-2 into R14. Move. I think that this is it's a 3E. How were we doing this yesterday? Was it that we weren't doing those maybe it's just because of the registers we're using, and maybe we can do like R15 to something else. Uh, 35, 40. It looks at the 40, so we were doing ads. Well, so those registers are already empty. 14 and 15 are already empty, so we don't have to do a move. We could do an add. Maybe that get us valid. Why were these okay? Was it just the register? I guess maybe it is the 14 and 15. Okay. What if we do move R4 to R15? That's not gonna work. I can already tell. But we could always ret if we have an address or something like that. E and 3F. Yeah. 3, 9. It looks like this is where it breaks. Yeah, so 8 and 9 is the highest we could go. I wonder if there's a way to get R9 or something and R10 into R15 and 14. Zero E is not going to be okay. We can't push. That works. we can do add byte. Which I don't know if this will end up so R15 has the address. Let's say we execute this. So we need a lot of we could theoretically write to like 30. It's like theoretically, right? Like in here, we would jump back to here, read in more here, and then jump back. I don't know, maybe this will work. let's try it as this. We can't move R11 into R15, can we? Yeah, that's not going to work. So we're going to want to do, I guess that's the one thing like we can kind of ignore is like so I guess let's say we assemble this. This is our shellcode. We're going to go to D0, which is we're going to start at 4430, I believe. So zero. So we're going to start at 4430. 4430 minus after our 17 would be 4400. Oops. 48. So I think that this will get us at least to start adding up the values. What? I have three, 8. Where did that 3 come from? Right. Because I didn't convert this to... All right. Where's PC? PC, here's... Okay. So it seems like we can take this approach. I wonder if we could move SP into R15 or R14. No. That doesn't get us anything useful, unfortunately. Yeah, as we have to use the bytes, unfortunately. And I don't know if we can get a big enough number in there fast enough. So let's see how big. So all those A's. Right now, all those A's don't do anything. Could you put some binary code in that place to set the return to land in that code? So I can't land there. So the reason I'm landing here rather than in here or here is that the address of here and here isn't an alphanumeric. So give me 1 second and I'll show you what I mean. So continue. So this is where our input starts landing or gets copied. So this is an alphanumeric, and we don't get to alphanumeric until down here at 4430. So we're kind of limited in like where we can actually put our code, unless we can find a gadget or get assembly that will jump backwards. I don't think any of the jumps are printable, except for maybe like a branch instruction. But I don't think branches work backwards in what we can print. I don't know why that gave us an unaligned issue. Why do you think we're unaligned? We're definitely not unaligned. 3850. This should be aligned. We're at 4141. So we overwrote. That's bizarre. Why do you think we're... I mean, even down to here, we should be fine. Okay. Oh. That's why. We're overwriting into we're overriding into this function that we're calling. So we're gonna run up against that limit. And I don't think we can do maybe we can do a branch. Two. Like, what is that? can't do a simple jump backwards. In say we just started with this, like what can we actually get up to if we don't overwrite that? I think this is enough to not overwrite the function. No, we still did it. Yeah, I get to like E7, which is not even remotely like helpful to us. And like the funny thing is, we can make it say access granted. All we have to do is basically overwrite like this instruction with like a ret, and I don't know, put like 1 or 0 into R15. I forget what the access granted 5EA. So it would even be like 1. We would just need to put like a non-zero number in R15, and we can make it say like we got in. But like yeah, if we what is it? It's a 3041. What is 30-0? I think that is it. Maybe I need to swap the order. Yeah, so it says access granted, which is like, you know, we made it say the word, but it doesn't actually like do anything meaningful for us. So we're not going to be able to do maybe we ROP a value into there, and so -4 from R15 is where we want to write to. No, it's all zeros. So like right here, this is just the hex dump. Where is it? Yeah, this is the hex dump symbol for like saying it's all repetitive here. So it's all zeros. Like we could theoretically write into there and jump into there, which maybe we'll do. So we might be able to combine ROP here. Then that's what I'm looking at right now, because we have this gadget and we can move into R15, which is the big number we need. So like, let's just say we wanted to do this. So let's get a number into R4. So what's 6C? 6C is L. Oops. So for our chain looked like pop R4. We're gonna pop R4. We're gonna move -4 of R4 into R15. That gets us a value into R15. We're going to lose some stack space because it's going to add. So we need to account for that. So what is that? That's L, and 44 is D. So we pop R4. We then do what's 64? That's lowercase d. DD. 44, 64. That's 44, 6C. And we now have something that we can control that's in R15 that is, you know, something useful, I guess. So the first thing we're gonna do is we're gonna pop. So this next value is what we're gonna put in there. So say we wanted to write 44, I don't know. Just for the sake of it, we can try 3030. 3030 is 0, 0. Actually, so we'd want to do we need to put so 4 bytes from here. I guess we could reuse some of this. So 44, 34. What's 3, 4? That's 4. 4. And 44 is D. So we're going to pop 4D. Pop 4D into R4. And then we're going to move whatever is there. Into R15. Then we need to get something into R14. Oh. We don't care about R4 after this. $30 is 0, 0. And we're going to call get S. N, which is 5046. 50 is P, and 46 is F. So PF. PF. Let's see if this does what we think it's going to do. Continue. We're going to ret to here. We're going to pop R4. And it's going to have 4434 in it. Oh, but we're only moving the byte. Shit. If only we could get like R11 into R15. Or R4 into R15. And yeah, this isn't particularly helpful. And there's not like another one we can get, is there? There is. That's not usable. Let's move byte. Move byte. Yeah, and this is all non-alphanumeric again. Source of 22 we can't use. None of these we can use. I wonder if none of this is. Oh, some of this is usable. 44, 70. What is ret? It's 3041. Yeah. And 0A. None of these are going to be usable. Damn. because doing all of this is going to end up clearing R15. There's no way we can get something into R15. Like, we can't do R4. Zero F. Add with carry. The only adds we get are add byte. Maybe there's like another instruction we can do. We could subtract maybe. That'll store it in R4 though. That's not going to help us. Can't do swap. We could maybe shift. Like what's RRC R15? What if we want to do a left shift? RRA. Yeah, well, that's not going to be helpful. Is there like a negation? Bit clear, test bits. I wish we could do swap bytes. But I don't think we can. Yeah. Hit F10 and like that's not natively in there, is it? No, we would see it if it was a gadget we could actually use. I just wish we could use this. Like this would be perfect. What is 22? That's not what I wanted. 22 is quote. We get nothing because it's not alphanumeric. Can we move R12 to R15? No. Yeah. so swapping bytes, if we can get like 42 into R15, if we do a swap byte on it, it'll swap the least significant and the most significant bytes of the word. So it'll become like hex 4200 rather than 0042. And at least that would get us like closer to here. We get like 44 into like the low low bytes. Right. So the swap B instruction we can use, but it doesn't assemble to something that's alphanumeric. Like we get it's 8F10, which is outside the ASCII range, and this is a new line. Yeah, I mean that's like really the hard part about this is just the very limited number of bytes we get to like work with. Um, it's a pretty like full featured architecture. Like it gives you a lot of power, and like there's some like really creative things we could do. It's just that I just am running out of ideas in terms of like ways that we can get meaningful values in. Like the get string is interesting. Like getting to the point where we could call that again. Um, I mean, I guess we could call it on 0, um, but or even like 42, just to get past 10, and write like something up here, but I just don't see an easy way for us to get meaningful values into R15, or R14 for that matter. Like maybe we can. Like we've got some naturally occurring useful stuff here, but it's just not. It's not reachable. What if we could call memset and change something? To assignment in the alphanumeric space. we get anything into R14? I think we do add B and like 6F to R14. I think we can do this. What does that return if we do get string? It puts, moves the stack pointer into R15. Let's put char. And like we wouldn't be able to jump to any of that. Is add B emulated, or is it? Destination. Yeah, it doesn't help us. Still have the 1E. Yeah, how do we negate something? Is there a there's no there's not like an invert, is there? Like we can subtract, because it's all one's complement, but there's not like a like an invert instruction, I don't think. I guess we could XOR. Yeah, so one's complement is one of the methods for storing negative numbers. Like most modern computers will use two's complement, which is so like say you wanted the number, I don't know, like -5. So this is 5. So the one's complement would be that. The two's complement would be this. So this is -5 and one's complement. This is -5 and two's complement, and this is 5. Yeah, so we can try XOR and see if what that encodes to. 3E, E3. Yeah. So I don't think this is gonna end up working. Cause I think the E0 is still R15. Oh, maybe it's not the E0, it's the 7E. I guess we could flip it that way though. I mean, we still have the null byte here though. Is XOR W XOR word? Oh, it must be. So this might work. Oh no, E0 is still there. We wouldn't be able to use that. Is this just the same thing? Yeah, it's the same thing. Yeah, I mean, it seems like everything that's word based all has a an E0 or some alphanumeric byte in it. This definitely is by far the most difficult one I've done, I think, so far on this game. And it clears R15, which is unfortunate. I wonder if we could. I don't think we have looping constructs. As I'd say, we can use get char and just build ourselves a loop to get as many bytes as we need. So, I mean, we could overwrite the memset call so that never gets made. And that means that our original code would still exist up here, which could have non-printable characters after a certain point. How much space does it take to get there? So we start right here. Where is memset? Memset's at 4. Yeah, so 4, 5, D6. Minus, where is this starting? 4, 3, F. 4, 3, E, D. So that's could we get back to there? Like, so say we did 489 bytes. Would we still have all of data in here? It'll be 49, 490. And then so where's the rest of our data? Load address would wrap. Are we still in here? 46EA. What? 4, 5, D6. 4, 3. 4, 3, E. There's a lot. What the fuck is all this? I'm kind of confused. If we look at where this is writing, it writes it into 2400. 1, 2, 3, 4. That's 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. 100, 200, 300, 400, 500. Oh. So for some reason, this all gets copied up to here, and then this is all in here. And then memset gets we've overwritten not enough bytes. We're only at A2. If we reset this, that should get us past there. We're at a different spot now. Oh. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Yeah, so for whatever reason, it's stopping the copying. Oh, probably because we're like breaking it. So we're never getting to a point where we stop that. what does this do? It's a jump -4. So that's interesting. 3F. What is 3F? 3F is a question mark. But that's interesting. These are all minus, or is there a plus? Whoa. That's, oh, it's at PC to 15. That's less helpful. But, so these jumps. Three Fs. And how far is... Four, 4, 6, 4, 3, 0. So we can, if we try doing that, we're just past the mem set. mean, that's not, it's far, but it's not far enough to, I think, be like really useful. Well, I wonder if we can jump forward. 3F, 3F. D. What's the end of this? 3, 3, 9. Jump lower. So like, where are we right now? Say we're at 40, 30 plus 62. 40, 92. Maybe we can use this to get one of the jumps that we didn't know. Yeah, I don't know. Maybe book it up tomorrow. I'm at a point where I got some more ideas, but it's just kind of all a blur. I'm gonna save where we're at, but everyone, I hope you learned something and that found this at least somewhat interesting. Hopefully, the next time we'll be able to solve this. I feel like we're just trying a bunch of things and figuring out what doesn't work. Hopefully, we'll eventually get to a point where we figure out what does work. Good chance I might do some streaming tomorrow. If not tomorrow, then at least what's today, Wednesday? Probably Friday. If you follow on here, you'll get notified, or on Twitter, I usually post. Anyway, have a good night, everyone.